We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of day or night to check stock on your favorite brands, such as Copeland, Sporland, Carlisle compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
John, how can you always have the right TV for the right application without carrying hundreds of valves on your truck?
You can carry the hundreds of valves on a trailer behind your truck.
That's too funny. That would work, but how are you going to do that? Maybe there's an easier way.
You can use Sporland's interchangeable cartridge style Type Q and Type BQ TEVs. Type Q is a conventional design and Type BQ is a balanced port TEV.
Well, come on, I need easy. How easy is it?
Easy as 1, 2, 3.
And it serves thousands of unique applications. So what's the process? How do I put this together?
First, you select the thermostatic element assembly. Then you select the body that you need. Then you select the right size cartridge for the application to get the proper capacity TEV for your application. And then I guess it should also be said you want to actually assemble those into a single valve.
That'd probably be a good idea.
Indeed.
These easy to select and assemble valves mean you're always carrying the right valve for the right job then. If folks want to learn more, what do they do?
You can go to sporland.com and find more information on the Type Q and BQ thermostatic expansion valves.
I guess that's Jim and John for Sporland signing off.
What's going on, everybody, and welcome to Advanced Refrigeration Podcast. You're with your hosts, Brett Wetzel and Kevin Compass. What are you doing?
Oh, I am just got home, been running around playing Apprentice all week, for the most part, doing wonderful case drains, and then EMS quotes all week. So I've been combing through stores that are, ancient, old, beat up, on their third or fourth EMS retrofit, and getting them ready for number 5, hopefully.
Wait a minute. How does that work? How do you get 5 different upgrades?
Well, I mean, it's that old, and it had some Danfoss, some ELI, some Comptrol, then to some Emerson, and now she's going back to Danfoss.
Really?
Yes. So you can only imagine how bad some of this looks.
Well, yeah, I'm sure they quote in home runs for every single comm line, right?
I did on these stores. They I'm not dealing with it. Like, honestly, I think it's just bad. Like, there's splices everywhere. There's butt connectors, wire nuts. I mean, they're guts. Like, the racks need gutted. The HVAC units need gutted. Pretty much the entire store needs gutted. They don't need a control system. They need, new equipment.
And you're not doing that. You're just upgrading the EMS for the umpteenth time.
Yes.
That's silly.
These racks are in like season 4 rack houses.
Oh boy.
They are old. Like these are Hill racks before they were Hill Phoenix.
So the orange ones?
Yes.
Oh man, that's like, I think, is that late 80s, early 90s?
Oh, actually, this would be number 6 because it had an IPC on it at one time. So this would be controller number 6. At what point do you just say it's time for some new equipment?
Well, maybe they just need EMS, really good EMS, to make sure it catches all the issues because everything's so old. Maybe.
Yeah, like the whole store is an issue. Like
Just-
the HVAC. Put it this way: the sprinklers were on yesterday. It was 54 degrees outside, and the head pressure was still like 220.
Yeah, but there could be copious amounts of non-condensables in there too.
Oh no, that drop leg was warm.
No, okay. What's that?
Yeah, it was warm. There's those condensers have seen better years, not days, years.
Sweet.
So yeah, I'm doing that stuff. What about you?
I'm actually in Houston. I was told that we aren't moving the Houston Training Center for now, so I'm upgrading it. So I had to get measurements. I have the footprint of what the square footage area that it takes up, and there are certain things I'm upgrading and certain things that I want to add to bring it up to the most recent stuff out there. And so I was taking measurements and seeing what I had to extend and see what I had to subtract, and just set up my footprint to put up some training boards in Fullerton. We have some training boards that have VFDs on them and stuff. So in part of one of our level classes, they can, hook up a VFD with a bypass contactor and all that other stuff that's already mounted on the wall. Just there's one single VFD that runs, one small motor, and, they hook it up accordingly to the way it should be, and, watch it run just to make sure they understand like how the, how the bypass contactor works with the inverter contactor, and making sure that the interlock is there so you can't pull in both contactors and so you don't blow the VFD off the wall.
Because the last 3 racks I went to go start up, the VFD incoming and outgoing powers flipped around. So that's something I check at every startup now, because the first time I turned it on, it went boom. It blew up the drive.
Yeah,
I've seen the last 3 startups.
Yeah, I forewarned someone about that same thing, and I think they found the same thing.
Yeah, it's I'll tell you what, that was loud, and thank God it was the low temp, the small drive.
Mm-hmm. Why do you say that?
Because it's about half the size, and it's like a 20 amp breaker instead of a 70 amp breaker.
Okay, just for the sheer boom factor of which one
like
it was.
it's a little less boom, little less little smaller. You don't have to, you're not lugging up a 100-pound drive. It's a drive you can put up with one hand.
Cool. Yeah, I'm down here just figuring out where to put stuff. I don't know, and just figuring out, because I want to put some other equipment, because we're going to be starting some newer classes. I don't know. There's just a lot of things that we're trying to do, and in order to be able to do everything that I need to, I need the lab work in order to teach some of those specific harder classes. So that's what I'm doing.
Sounds good. Well, tonight, guys, we're going to go over some case airflow stuff. Seen this come up quite a bit here lately, and then it's caused some issues here and there with with stuff I'm doing. So Brett wanted to talk about some airflow stuff. So we're going to go over evaporators and condenser airflow and some design stuff. So tonight, guys, we're going to start out with the going over like case evaporator airflow. So I mean, that's one of your 3 pillars of Brett's triangle is airflow. Airflow is probably one of the most important things. If you don't have airflow, you can't make food cold. So, I mean, just, checking out case airflow, guys, with the back of your hand, just doing a quick test, through a case to see if you feel anything. I mean, that's not the most, precise way, but you know what? It'll give you a feeling right away if a case is iced up or not, at least, like iced up bad enough where it's causing a service call. So just taking your guys' hand and, feeling that case airflow. Now, airflow is dependent on you having all your motors going, all your coils cleaned, all your honeycombs cleaned, any baffles cleaned. So there's a lot of different things that could cause airflow issues, guys. It could be, go ahead, Brett.
Oh, the baffles is one thing I want to hit on just a lot. I mean, obviously you should be checking when you're checking airflow, you want to check it either with an Alnor Junior, Testo 410A. There's a Kestel 205 that people use, anything that has that little impeller on there. The Alnor Junior is what everyone used to use at the factory. And actually Hill Phoenix did make a metal sheathing for it. So, it basically hooks right up to there. But unfortunately, you can't find the Alnor Juniors anymore unless you're, looking on eBay and someone just so happens to have one. They can calibrate them, but they just don't make them anymore. And the airflow that we're checking for is measured in feet per minute. Normally, like Kevin said, it always wants to be checked directly after a defrost to make sure you do have the correct amount of airflow. But those baffles have screwed a lot of techs over because, I checked the honeycombs, that's fine. I checked the coil, that's fine. So why else wouldn't the thing actually pull down the temp not have the proper amount of airflow? And a lot of times it's the fans or what have you. Go ahead.
So with those baffles, I just want to throw this out here, guys. Not every baffle's in the same place. Okay. So like some older Tyler cases, the baffles used to be behind the fans on the coil. Some of the some random cases, they were in the back wall above the coil. And then sometimes there's older Hill Phoenix cases where they're actually in where the curve is in the back wall, where you have your transition from the back wall to the upper deck where the honeycombs airflow is. The baffle's in there. In some Husband cases, the baffle is literally in behind the honeycombs. So like you really got to check this out. Like, I mean, if I'm like, look at this, like I have a rigid, like not a rigid, but a Milwaukee Sea Snake, like one of those cheap, like $80, like, flexible cameras. And I'll drop it down the back wall and make sure there's no honeycombs or any baffles back there. Because I've seen guys clean cases, they clean a coil, they clean the fans, they're all good. They clean the honeycombs, and they still have the low airflow. And then they start changing motors or start, bending blades when really it's a baffle issue. I mean, think about how many times a lot of these stores get neglected on maintenance, and the baffles get missed in the back walls. Like I was just on a case. We were out there like 6 times for these produce cases. They continue to ice up, nonstop problems. And they cleaned the coils. They cleaned the honeycombs. They were filthy. Okay. Well, nobody caught the back wall baffles. And they were in a weird spot. They were on the upper side. They were the baffles on the right before it turned. Go ahead, Brett.
No. I'm sorry. I was envisioning what you were saying. So I was pointing up. I was seeing where that baffle was. Sorry.
Yeah, so like they were actually, if you pulled the back wall down and you look down, there's no baffles. If you looked up, right before the curve is a set of baffles, and that's what was in there, and that's what was causing. I mean, they were plugged solid. I mean, it was dropping the airflow 80 to 100 feet per minute, and that was enough where it was allowing warm air to come in and ice these cases up because the customer had such a stringent defrost spec, and they were rigid on it. They weren't moving off of it. So, I mean, that's one thing to keep in mind, guys, is these baffles are they'll get you. I mean, they've got me, they've gotten Brett, I'm sure. I mean, they'll get you. I mean, they're not in every case. And unfortunately, most cases, go ahead, Brett.
No, I was going to say, because I've called the manufacturer already. I was like, yeah, I'm just going to call the manufacturer because he'll be able to tell me, if the baffle's behind there. Well, I've called one manufacturer and the guy there knows every bit about every case, whether it be Tyler any of the newer Hill Phoenix stuff, and like he knows everything about it. I called another manufacturer and was like, hey, where are these baffles? And he's like, no, there's no baffles in there. So I thought it was something else based off the information I was given. Well, the kid called me back like a week later because we ordered some shelf extenders for the thing, and to help with the airflow a little bit because that seemed to help. But when he took everything apart, he found baffles that were in there. So
yeah,
the best thing to do is investigate for yourself. That snake camera he's talking about is $80. Pop out one of the access plates in the back, look down, look up. The top flue deck, I don't know, I call it a flue deck. There's other names for it, but check up in there, behind there, just to make sure there's nothing there. The normal spot, like you said, behind in the right behind the fan motors, in some of the older Tyler cases, you'll see that. And then some of the ones you'll see, like in the Husband ones, you'll see right in the top of the honeycombs.
So the Husband cases, this is a huge problem with these, is the back walls on the 4-foot coil sections. The back walls will kind of cave in, because the stocker just shoves that product in there. And what happens is it'll actually like cave in and allow product to fall on top of the evaporator coil that's in the back wall. And it'll build up over time. Like, I swear, like I've seen pictures, and I had not noticed this until like a couple of years ago. I had a case running, 1 4-foot section, low airflow, and it caused the whole case to run warm, but one section had like shit airflow. And I'm looking at it. I know there's no baffles in this case. I'm looking at it. I got terrible airflow, and I look and I see it. I see something in the back wall through the slits. And I look, and sure as shit, there is like 7-year-old bacon back there. And not like a little bit of it, a lot of it. But like I've seen guys pull like cans of biscuits out of the back of these things. Like, I mean,
bacon.
It's pretty cool.
Bacon and hot dogs is usually what I see behind there.
Hot dogs are always back there for some reason. I don't understand why, but yeah, I mean those Husband cases, like be mindful of that. The metal's real cheap and it's springy. So like it'll spring back on you, and you won't notice it until that stocker's shoving it back there harder. I mean, that's one thing to check. Make sure you don't have like pushed in sections. So what I've done with those is I've taken strapping, like plumber strap, and shot it to the shelf so they can't push it back any farther if it is caving in back there. So just shoot some plumber strap to the shelf, drill down, and then drill into the back wall so it can't roll back any farther. So that's one way to keep it from like falling back there. And then just make sure there's nothing back there blocking it like that. And then second of all, next thing I want to go into is fan motors. Okay. ECM motors. Okay. A lot of these ECM retrofits are coming through, like energy companies are coming through retrofitting these motors. A lot of times it's not the refrigeration vendor doing it. It's a energy management company or the utility company doing it. So one thing to keep in mind, I mean, obviously they're not looking at every motor. They're ordering bulk motors and say they're using like random motors. Okay. Not every ECM motor, even though it says it's 9 to 16 watts, is the correct motor. So you need to make sure that motor has the correct height to it. I've seen a couple ECM motors where the height is not right. So like the Tyler ones, for example, like my go-to motor is a 5411 EC. It's the US Rescue Motors. It's a great motor. It's 208, 230. It covers like, I think 9 watts to 24 watts or 25 watts. It's an awesome motor. Okay. But like if you put that in a Tyler case where the square motors used to be, the square ECM motors, it's a 1/4 inch too short. So it actually lowers the blade down in the bucket, and then that reduces your airflow dramatically because now that blade is cavitating. So what you have to do is they sell a bracket extender, and it's like a 1/4 inch higher, and you have to have that bracket extender. Now, if you don't have that and you know what it is, you could use some washers to get you by. There's bolts in there, and enough to get you by. So that's one thing, but like, make sure it's got the right motor in there. Make sure it's the right height. Like Husband puts in their frozen food doors, they put 25-watt motors in there, but they're shorter than most motors. So that ECM 5411E will fit, but most other ECM motors will not. They'll be too tall. and it pushes the blade farther out of the plenum, and it reduces your airflow. 1 or 2 of these motors later, and now your case has 50 to 60 CFM lower and or feet per minute lower out of this, and now you've changed the whole TD of the coil, and now you're not going to make product temps.
So let me preface this by just explaining that usually, typically with non-ECM motors, the more wattage it is, the higher the motor is. So if originally you had a Husband case that had a 4-watt fan motor in there, and you now throw a 9-watt fan motor in there, basically the height now is that 9-watt is going to be taller, right? So make sure you're putting the correct wattage in there. Also, just having one rogue fan motor that's either too low or too high will affect other areas of the case. So just be mindful of that. You might have one cavitating, and then the other one's deciding whether to pull the air out of the fan motor that's cavitating or across the coil the way it's intended to, which is also going to reduce the amount of airflow that you have as well. So just be mindful of that.
So we just had this at a big box store using glycol, and service department was out there like I don't even know how many times, replaced all these parts, and I've been saying it's airflow, for like months now, and they've been like kind of like the case comes and goes. Well, it turns out there was one ECM motor in the center of the case that the manufacturer had set like 600 RPMs lower than the other motors. So what was happening is the other motors were running, and then that motor was 600 RPMs less. So when they overloaded the case a little bit, it put a little bit more strain on the return and increased the static pressure. And then the other motors started pulling through that motor. So it ended up, messing up the airflow enough to where it would cause warm spots in the case. So with those ECM, those programmable ones, I mean, if you're having case issues and you're having airflow issues, you need to get in there and make sure that that motor is actually programmed right. I've seen replacement motors come from manufacturers not programmed at all. If you're going to get those motors, off the shelf, make sure you have, a programmer with you, like the little stick one, and make sure you unplug the fan motor power and you put the stick in there, because that thing will light you up like a son of a gun.
So
because that's the first time I did it. I did that.
The first time I used it, and because we all read the warnings on the side of the fan motor. Like there's a big tag that's actually attached to the casing of it. Well, the casing happened to come off when I took it out of the box, and I was like, "Fuck that! I don't need that." So I turned it on. I was like, "Well, wait a minute. This little watch battery on the side of this controller is no way going to be able to power this thing up." So I was like, "I definitely have to have it, connected to the 120." So I had it connected, and I had it stuck in the back, and I grabbed it from the side, and I got the shit knocked out of me. I was like, son of a bitch. I was so mad. I was like, maybe that was the reason for the case, and then I look a little bit further and I see the warning tag that's on there that says, hey, asshole, to make sure you don't have it plugged into 120 power or potential of shock. And I was like, stupid directions. Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westermeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode. Hello guys, this episode is brought to you by Fieldpiece. The tough wireless vacuum gauge MG44 from Fieldpiece is engineered to give you the reliable reading you need and the ease that you want. Confidently measure vacuums with a reliable leak-proof seal. The MG44 can be used with the JobLink system app from up to 1,000 feet away. This easy-to-read backlit LCD offers a graphical representation of the vacuum progress, even in low light or at odd angles. Visit www.fieldpiece.com for information or follow us on social media at Fieldpiece Products. Thanks again and enjoy the episode.
Oh, I did the same thing, word for word. I'm like, there's no way this thing doesn't need to be powered up to check it. But that's stupid. Why would it not need powered up? And then I get the shit shocked out of me, and I'm like, son of a bitch, stupid instructions.
Then you read it, you're like, maybe you should have made it better to read instead of being bright yellow. You know, I'm just saying.
We use red in this country.
I was so pissed. I was so pissed.
It was like after working, it was like hour number 12. I was tired. I wanted to go home, and it's just like the last thing. It's just like,
and sometimes they don't come programmed properly from some of the manufacturers, and you see 1800 RPM on there, and you're like, yeah, sure. You're just checking the airflow, and then you find out that it's low. And if it's a brand new case, then there's obviously a reason why. I mean, case hasn't even started up yet, so you can go through the case and measure the airflow, and that's what it was. It happened to, I don't know if it lost its program in transit or what, but it was marked for, because they usually have a little sticker around the plenum of the fan bracket, or right on the fan bracket. It'll say what it was originally supposed to be programmed for. So I would recommend just checking your airflow on a startup just to make sure you have, you should basically have all the same RPM for the same, style of model number for the same model number of the case, right?
So I'll caution you on that, because there's two manufacturers that do this now, that the meat cases and deli cases, they're single decks. Mm-hmm. They're 400 feet per minute different.
What?
So same, yes. So same thing with the Hussman ID case.
Mm-hmm.
The airflow on a meat ID case, at Aldi at least, is increased 200 to 400 feet per minute than in Hussman ID case, a deli case.
So if it's specified for either fresh meat or like packaged deli, there's a difference in airflow by how many feet per minute?
I think it's anywhere from 200 to 400 feet per minute.
Okay.
For RPMs. Yeah, there's a definite difference. I don't know if they stopped that. Like that was going around when they were doing these, because we had a bunch of meat cases come out, and we never could get the TDs right on, no matter what we did. Mm-hmm. It ended up being that we didn't have the right motors. They weren't programmed correctly from the factory to have that increased airflow on those meat cases to keep the glass from sweating. So, and then I know like Costco single decks, like Kaiser Warren, there's different, the meat and the deli cases are different airflows. And so same thing with Arneg. Arneg's the same way, like the meat single decks and the deli single decks. I think theirs go from like, some of them are like 900 and some of them are like 1500.
Well, I guess the assumption would be that the deli meat, or I'm sorry, the regular packaged meat is going to hold more heat, right? So you need more airflow to pick up that extra heat across there. That would be my thought.
Yeah, and more of an air curtain, because you have a lower. Usually the meat cases have a lower. I would think they have the product sitting lower, so there's less air infiltration. So they need more of an air curtain, maybe. I don't know. Maybe.
Also, in a lot of these cases, as far as the fresh meat cases, if you have a multi-deck and it's a Hill Phoenix case, you'll notice that when the shelf is at an angle, there's usually about 1.5 inch gap in the back there. Well, they sell shelf extenders to basically cover over that gap, because what will happen is, instead of the airflow going across the product, you'll have a call where you'll have the customer put it in and say, hey, there's excessive shrink. right? So you go there and you're like, oh, the case is pulling down temperature. Then you're like, well, I don't know. The case is pulling down temperature. It's going up in defrost the way it should be. You know, everything seems fine. But if you were to put a case temperature sensor on the, you know, basically the shelf, you'll see that there's a 4 to 6 degree variance versus what the, you know, discharge air is. So that gap needs to be covered up in order for the air to go all the way across. Because what'll happen is instead of that happening, it'll just come out the back wall, go directly down to the bottom deck that doesn't need the shelf extender. Air gets really cold at the bottom there, and usually the product at the bottom will be, you know, freezy cold, but then the shelf temperature will suck. And that's when, you know, those cases need that shelf extender in order to bridge that gap so the air can actually go across the product.
So once the shelves are set on startup, because the majority, all Hill Phoenix meat cases usually ship at these, most of the other cases do. So like on startup, they're all zip tight to the back of the shelf. So if you're not paying attention, you'll miss this. Now on startup, what I'll do is I'll walk around the pair of scissors and I'll snip every single. It takes forever. I mean, it takes me a good 2-3 hours on a full Hill Phoenix store to cut them all, because even when they're flat, there's still a little bit of a gap. So you want that backing plate all the way on there. Now, this is where it gets weird, though. Husband does not have that. And a lot of times you could fit 2 fingers behind the back wall. And I think that's why they have so many issues with these ID cases icing up now, because, I mean, there is no backer on the shelves of the ID cases. Like, it's not tight to the back of the even when they're straight, they're not tight. But when they're angled, you could literally fit two, almost 3 fingers back there.
Yeah, there's one customer that we deal with that doesn't have the shelf extenders on there, but they have some sort of cover that they put on there that acts like a shelf extender. Like, basically, you know, it's to make the shelf a little bit more decorative, and it actually goes all the way to the back wall. So they're inherently just, yeah, you know, just by putting that little piece of plastic in there, it's actually making the case work better, because they don't have the shelf extenders for that particular manufacturer. So, you know, covering that gap up will do wonders as far as your airflow.
Okay, guys, like motors and stuff. Now, when you're looking at like ECM motors, so an ECM motor, when the static pressure increases, meaning like there's a blockage, you know, on the inlet or the outlet, the static pressure increases, meaning you're doing more work. Like the motor is doing more work. An ECM motor will speed up and try to work harder, and your amp draw will increase. And that's why you'll see a lot of premature ECM failures. Now, a standard motor, what'll happen is you're going to see your amp draw go down. So as your static pressure increases and you start blocking off that standard mode, I'm sorry, your standard motor to prop motor is going to go up. But I mean, it's going to do less work. An ECM motor is going to do more work when you start blocking off the airflow and start increasing the static pressure. It speeds up to do more work. And a standard motor is going to do whatever work it can do. It's not going to increase. Now, when you block a prop motor, like a fan motor in a case, a condenser fan motor, when you block a prop motor, your amp draw is going to increase, not decrease. When you block a squirrel cage or a centrifugal blower or fan type, what's going to happen is your amp draw is going to decrease. So they go backwards. So that's one thing. If you're amping out these motors and they're higher, or like the ECM motor, the RPMs are going higher than what they should be, that's because that ECM motor is speeding up to try to make up for that airflow that it doesn't have, because it's trying to maintain a certain RPM and horsepower ratio. And if it can't get it, it starts speeding up more to maintain that. So that ECM motor is constantly trying to hit a target. And if it's not hitting it, it's going to keep going faster until it does. That's why you see a lot of ECM motor failures early on. You know, in cases, that's why ECM motors got a bad rap until they go ahead, Brett.
Well, no, what I was going to say is, like, so sometimes you'll see, as soon as you plug them in, they'll start up and they'll start spinning really fast, and then they basically usually slow down. See, I was also told that was affected off the temperature. Was I uninformed?
Yeah, it's not about temperature. It's about the load on the motor. It's trying to maintain that load to RPM ratio, and that's how it's deciding how fast it has to spin to get that. It's trying to maintain that certain airflow, by the RPMs of the motor, and then your blade is actually setting the airflow. So it's blade work versus RPM of the motor to get that certain horsepower amp draw ratio. So it's all in there in a board. It's communicating with it, and it's figuring out inside the motor. Okay, like I'm drawing this many amps. I'm doing this much work. I need to speed up, to maximize this, or I need to slow down and maximize it. That's why it's so important to have the correct OEM blades on there. But that's why if you're retrofitting motors, you really need to pay attention to this and do your homework and make sure everything's good and it's set up properly, because if it's not, and you have the wrong motor, the RPM, the wrong blade pitch, it's going to throw off everything, and you're redesigning the airflow for everything. That's why I'm not a fan of these QM sync motors. I don't know if you've seen them, Brett, like the silver QM. Like they were like a couple years ago, they were going around, like they were trying to get them big, like they're with the OEM or with the utility company out here. There's a rebate for them. They're not true ECM motors. They're like some kind of like hybrid motor. They're a little bit more efficient, but like in order to use their stuff, you have to use their blades. So you have to change the blades. Well, now you have all these people in here changing fan blades, and you're basically redesigning the entire airflow of the case by putting these in here. So that's one thing you got to watch when you're doing these retrofits. Make sure the blade is sitting proper. If you're on a walk-in, meaning you need to make sure the blade is properly between the shroud, spaced out enough between the shroud face and the shroud back, because if you're too far forward or back, you're going to cavitate the fan blade. And when you cavitate the fan blade, you're going to kill that motor early, and you're not going to move as much air. So you want to make sure that motor blade is properly positioned. I see this all the time where guys have changed motors in walk-ins, and they won't pay attention, or they just put it at the end of the shaft, or they put it like toward a bit too far back, and that blade is cavitating and you're losing airflow. And believe it or not, that's throwing off your coil TD, it's throwing off your defrost. It's going to cause issues. The other motors have to work harder now. So like, that's why blade placement and all that is super important, because otherwise you're going to cavitate those motors and cause them to fail early. That's why a lot of these, Heatcraft motors are burning out, because if you look, some of them, even from the factory, the blade placement's not right. If you look at like their diagram of how the blade placement's supposed to be, I find a lot of them on startup are too far back or way too far forward. So, a half an inch matters a lot, especially when you're talking 5 motors like that. You may have reduced the CFM through the coil a lot. Now it's throwing off your TD and your coil, may cause icing issues. So that's one thing to keep in mind, guys. It's not always just a defrost issue. It could be an airflow issue, causing that TD issue. So, make sure that those blades are all correct. Make sure the motors are correct. Make sure the RPMs are correct. And then like on all the new motors, make sure the speeds are correct. Go ahead.
Well, so I haven't seen any newer postings in any of the IOM manuals where it actually tells you the fan pitch and all that other jazz. Like it's usually I have to call, this one guy to get any kind of information, like as far as fan blades and stuff. They putting that in at least in the parts part of the book of the IOM manual.
Craft used to, but it's to the point where like usually it's like 1/3 of the blade sticking out of the shroud on a Heatcraft. Usually right about where I see most of them. Usually if they're farther back, then there's a problem, but they used to put it in there. But yeah, now you got to call. So if you're having issues, you need to call, or if you have a ton of stuff like that, you need to call. I know Crack doesn't.
So sorry.
Crack doesn't put any of that in their manuals. So,
well, we had a problem. Heatcraft made these triangle style evaporators that were in one of a major chain, and they had a beacon system in there, and these things would run, even though they were designed for a 10-degree TD, they were running 15, which, messed up the expansion valve sizing and all this other jazz. And I was like, so where are these blades supposed to be? And he had sent me a document on, how it was supposed to be set up, and come to find out it was totally opposite. Like they told him how far it needed to be, and they were measuring from the wrong direction of the end of the shaft. So it ended up throwing it way off, which, essentially raised the TD because it was less airflow that was going across the thing. And this thing, these evaporators just struggled for the life of them to maintain a good superheat all the time, because it would constantly flood and starve because of the lack of airflow. So you'd think airflow doesn't have that much of a decision on whether your shit's messed up or not, but it does a lot. Go ahead.
So these triangle evaporators, like they were 3-sided evaporators, like were they like low profiles?
Yes. So they
really,
you remember the old school ones where you had to drop down the whole front in order to access the fan blade, the motors,
like the horseshoe ones, like the really, really old ones.
No, I'll look it up and I'll show you a picture. But basically where it pulls the air directly through everything. And what made it worse, it was opposite. Like typically on a regular evaporator, it's drawing the air from the back and blowing it out the front. These were pulling from the front and throwing it through the evaporator. And, because of the way the drain pan was, it was, if the gap was too much there, that also messed up the amount of airflow. So like any small movement that you did as far as when putting it back together, if it wasn't put back together 100% perfect, you had impurities on how bad the airflow was, which would cause the unit to have icing issues constantly.
That sounds like a nightmare. I am not a fan of low profile coils. Low profile coils are just a nightmare. I mean,
center fan ones aren't that bad, but it's the real tiny shit.
I mean, guys, that's another thing. Brett, we're talking about low profile coils. A lot of low profile coils, suck in from the fans and blow out and then blow through the coils. With that being said, I mean, you could have low profile coils that look completely clean and not iced up, and the whole inside of the coil could be a solid block of ice or completely plugged with shit, like prep room coils. Prep room coils always look clean on the outside because they get hosed down nonstop, but like the insides look like, they cut a couple cats up in there. I mean, so that's another thing, like just, actually get in there and look at the evaporators. Same thing with like cases, guys. I mean, they can look clean behind those fans, but I mean, you get, behind the shroud, where you can't see, like especially Hill Phoenix cases with those tight coil spin spacings and like the NRG cases. I don't know how many times I've seen guys miss a, plug coil, and it's just like absolutely plugged, but behind the fans, it's got a little more static pressure. So it's pushing that dirt farther in the coil, and it looks somewhat clean behind the fans, but like everywhere else is just filthy dirty. So that's another thing. I mean, you flip that plenum over and see what's actually going on there.
Those guys.
Oh.
You're pulling the air directly through there, and then shit. Like usually the thing it would be going this way. No. This is reversed. And so basically the right where this is, the fan blade was all the way as farther away as humanly possible. So like it wasn't the normal, 1/3 or 2/3 way through the coil. It was just totally messing up the airflow.
That looks like a pain in the ass to work on.
Yeah, well then the controller would actually be up in the middle. So like on this particular unit that I'm showing you, basically right in between the two fan blades is where the controller would go, is where the beacon board would go.
Yeah, with that being said, guys, with like newer coils, so if you do not have anything to control the fan speed and the customer's not doing it, make sure you jump that thing out and let it eat high speed all day long. So, I mean, I've seen that on multiple startups now where boxes struggle to make temp after defrost, and I've seen the fan speed not disabled, so it was running low speed. That low speed's not enough in refrigeration to do all your cooling. So I mean, it's not going to remove enough heat out of that room fast enough, and it's going to throw off the TD, the coils. So make sure you're in high speed. I've only seen one customer utilize the fan speed control. So to me, it's like the biggest waste of money right now.
On some of the newer case controllers, I just got what the hell is it? It's a KE2 essentially, but it's what they put on all the Trenton coils that you get from United. They have an ESP controller on there, and on there they actually have an analog output for the ECM fan motors that you were talking about the other week, that are derived off a signal. And then I also saw a relay that was designed for the two speed. I think it was the QRC controller as well does that as well.
So I guess those Dixels, remember that guy from Emerson did say you could do it with the Dixels. It's a lot of like background programming, but they could also do that analog output for the fans. But I mean, I just don't see they're overhandling like some of that stuff. Like that's really overhandled at that point. It doesn't need to be that complicated. I mean, now you're talking about changing TDs, and you're changing a lot of stuff on the fly. I mean, and expecting a system to adapt and go over it with a probably condensing unit that's sized for 120 degree ambient and probably way oversized, and it's probably 60 degrees outside.
Blame the Department of Energy. That's all their fault.
Yeah.
All this wackiness as far as the crazy energy efficiency stuff, this is all the Department of Energy forcing the manufacturers to be like, you need to make it run at this. Okay. What are you going to do?
Except for the units. I'm starting up in a week. They came out with 180-pound headmasters.
What's wrong
Zero
with that?
fucks given.
What's wrong with that? Bump your fan cycling up really, really high.
No, they came out with 180-pound headmasters, so that's not AFE required or
AWF,
compatible. Yeah. AWF or whatever acronym that 3-letter acronym that the government uses to ruin everything.
Hold on. AWF is 4. AWEF. That's 4, not 3.
Oh, well, they fucked it up. Usually it's 3. Like the FBI and the alphabet boys. So condenser airflow.
Nah.
What?
We'll push it off.
Push it off?
Yeah, push
Make
it
another
off.
one?
Yeah. That sounds good. We don't want to bore you guys with airflow all tonight.
All right, guys. Thanks for listening, and have a nice night.
See you guys later.